Okay, let's have a look at simplifying ratios. So why are we going to simplify ratios? Well, when numbers in a ratio are multiplied or divided by the same number to obtain another ratio, these two ratios are said to be equivalent. Now that'll make a bit more sense later. So what does this actually look like? Well, let's have a look at the ratio 16 to 24. So if we look at this ratio here, we were asked to simplify it. Well, as we know, simplifying, as we probably know from fractions, simplifying means to reduce to the lowest possible term. So one thing we're actually going to use here, or we're going to look for, is the highest common factor. That is, determine the largest number that both of these things here can be divided by to actually give us a smaller ratio. So let's have a look here. So the way I like to do this is to draw a couple of arrows here. Okay, so let's have a look at these two numbers. What is our highest common factor here? Well, I'm going to say the highest common factor here is 8 because, well, 2 times 8 is 16 and 3 times 8 is 24. So let's do this one first. If I divided this side by 8 here, well, I'd end up with 2. So I'm going to put my little ratio sign here. Now, whatever I do to one side, in order to keep them the same or equivalent, I need to do that exact same thing to the other side here. So if I divided that by 8, it would be 3. So that means our simplified ratio, we can't go any further than this because there's no common factors between 2 and 3, besides 1 or themselves. So this means right here, I've actually simplified my ratio. So let's see how that might look using a bit harder of an example, okay? So if we had 45 centimeters to 1.5 meters. So what we learnt before is, well, we can't do anything with ratios until these are the same units, okay? And we want them to be whole units. So that means I'm going to rewrite this here. 45 centimeters to, well, 1.5 meters is 150 centimeters. Okay, let's look at this. Can I work with this now? Centimeters, yes, cool. This means I can write it as a ratio by docking the units and using my little dots. So our ratio here becomes 45 to 150. Now, let's have a look at simplifying this here. So I'm going to draw my two little arrows here. So I know to do to one side what I do to the other. Well, let's start off and think, well, I know they both have, one ends in 5 and one ends in 0. So this means they're both going to be divisible by 5. So I'm just going to do that first. So if I did 45 divided by 5, that's going to be 9. And if I did 150 divided by 5, that's going to be 30. I think I can actually still do more here. Now I know that 9 and 30 are both divisible by 3. So if I divide that by 3 here, well, I need to do it to the other side as well. So let's divide that by 3. So 3 3s are 9, and 30 divided by 3 is 10. So if I look at this here, so I say, can I go any further down? Well, no, there are no more factors between 3 and 10. So here I've found my, I've simplified this ratio. Now, if I was a little cleverer at the start, I could have very well gone, oh well, 45 divided by 15 is 3, and 150 divided by 15 is 10. You see, I'm doing the same thing. However, I've done it in stages here just to prove that even though you can't think of it, or if you have working with very high numbers here and you can't think of the biggest number possible to reduce them to, you can do it in stages as long as you remember to divide by the same thing on each side to keep it equivalent. And that is how we simplify a ratio. We essentially write it, we draw our little arrows to show that they're both going to be reduced, and you make sure you do the same thing to each side to reduce it down. And that is how you simplify a ratio.